Hey again, everybody. It's me, the substitute teacher. I'm back at it again, teaching you over there in internet land about Chemistry 12. Today we're going to be looking at how to calculate the mass of sodium iodide necessary to begin a precipitation of copper 1 from a 250 milliliter sample of 0.01 molar copper 1 nitrate. My bad. Just substitute teacher. A little confused sometimes. Okay, do you guys have your calculators ready? Because I certainly do. I'll hold that. Yay, I'm holding it. Don't put it in my mouth though. That's bad. That's bad. Don't put it in the mouth. And you should have a periodic table like this one I got. Okay, there we go. Now that we're ready to go, let's start doing this. Okay, so first off, we should realize that Na is just a spectator ion. So, gotta get rid of the Na. Get rid of it just like that, right? I didn't realize my hand got in the way here. Now, so we're gonna write this out, and we're gonna write Cui. Oh god, bad writing, bad messy writing. Forms the precipitate. Oh, that is the precipitate. Cu plus I minus. Just like that. So we have our formula right here. Now, since copper nitrate is a 0.01 mixture, this means the copper is going to be also 0.01 molarity, and we need to find out what is the concentration of the iodide in there. So first thing we're going to do is we're going to write a KSP expression. KSP equals, and we're going to write yeah, Cu plus times I minus. I did it. There we go. Now, we're going to use our table right here and look up copper 1 iodide, and that's going to be our KSP. So KSP is going to be 1.3 times, a little bit tired, guys. I had a long day today teaching. 1.3 times 10 to the minus 12 equals Cu 0.01 molar times X. Nice. Now I need to figure out what is X, or in other words, our concentration of iodide. Oh, I'm so tired, guys. Substitute teaching is hard work. I've been working all day. That's why I'm yawning so much. Bear with me here. So I solve this and calculate what X is. So I go 1.3 times 10 to the negative 12 divided by 0.01. And I think I could do that in my head. 1.3 times 10 to the minus 10. And that's going to equal X. Okay? There we go. Now we found this is actually going to be the concentration of, yeah, I know. This is going to be the concentration of our I. Okay? You see that? Whoa, whoa. So we calculate the concentration of I. Time for a dance party. Woo! Now, you can use your calculator too if you want that. I got mine right here. Never leave home without it. Put it back. Now, but the question doesn't ask us what's the concentration of I. It says what is the mass of NaI that we need. So if this is the concentration, I'm going to convert this into how many moles we need. We have the volume right here, so we'll calculate moles. 1.3 times 10 to the minus 10 molarity, times that by our number of liters, which is going to be 0.25 liters. I converted this milliliters into liters right there, and that's going to equal my moles. So, use my calculator again, just like that, and we're going to go 1.3 times 10 to the minus 10 times 0.25 equals, and I get 3.25. See, I did it. 3.25 times 10 to the minus 11. Oh, awkward. Hope you guys didn't watch that. That was gross. So, that is how many moles of Na I need. Okay, so I have 3.25. Yeah, use the calculator some more if you need to. 3.25 times 10 to the minus 11 moles of NaI. Now I need to convert that into grams. So times by our molar mass of NaI. So we use our periodic table, like this one. You should have a periodic table. Now, Na molar mass is 23, and I is 126.9, and that's going to equal 149.9. Oh, no, I can't remember the number now. What did I say? 149.9? I accidentally erased it on my calculator. What did I say? 23 plus 126.9 equals 149.9. I did say that. And that's going to be grams over moles. I'm sorry I'm writing like this. I am only 4 months old, guys. Bear with me right here. So moles is going to cancel out. Let's change the color on my pen so you can see that. Moles cancels out, and I'm left with grams of NaI. Oh, I should change the equals. Getting a little agitated, guys. I really want to use... I think I spilled some chocolate on this calculator because I really want to put it in my mouth right now. Anyways, we're going to go 3.25 times 10 to the minus 11. I know, I'm just so excited to answer the question, man. Times 149.9 equals, oh, I need to get a new calculator, but this is just going to equal, this number is not exactly perfect, but it's going to be 5.0 times 10 to the, whoa, let me calc some, look at how many, 1, 2, 3, 4, 5, 6, 7, 8, 9, times 10 to the 9, oh, I just kind of erased it by accident, times -9, -9, that's really hard to hear, see, grams, I'm going to write it over here so it's a little bit more clear, I'm getting a little frustrated here, guys, I'm not going to lie to you, 5.0 times 10 to the, oh god, gotta grab one. Here, you can, I'm just gonna show this calculator to everyone. Here you go, there you go. 5.0. It just tastes like chocolate, guys. It's so good. 5.0 times 10 to the minus 9 grams of NaI. That's the problem right there. Oh yeah. Okay, so as you can see, I technically solved the answer. I might not have been as good or as graceful as, this is gonna wipe that off of my shirt, as good as the real teacher, but, you know, I technically did it. I still know chemistry. I taught you some chemistry. Hopefully you know how to do KSP stuff too, and how to use your KSP tables. I'm a little bit rambunctious today. I'm sorry. I probably could have answered this way quicker, but, you know, substitute teacher of the year, did it all by myself, 4 months old. I'll show you what 4 months looks like. If I can show up some fingers, I'll do it tomorrow maybe, okay? So I just really want this calculator. I just need to get this calculator again, okay? Okay, this calculator is just awesome. Yeah, it's good. Oh, okay. You want the yeah, I just love this calculator, guys. It's just awesome. Okay. Anyway, there's buttons. It's kind of cool. It's Texas Instruments. They're not sponsoring this channel, but you know, shout out Texas Instruments, sponsor me, guys. Anyways, I gotta go.